All right. Hi, everybody. Thank you so much for coming to the demo days. It's August 4th. Again, these are every 2 weeks. So remember, if you have something to present for the next 2 weeks, please sign up on the Google Doc that we post in Slack. This is a quick reminder. If anyone has any questions during any of the demos, to please post those in Slack as well. They'll be answered async, and then anyone who missed this live session will understand your question as well and be able to see the answer that way too. So we have 3 demos going on today, it looks like. We have PegaSys doing a file retrieving, Myel, I think I'm pronouncing it correctly, looking at lazy retrievals, and then we have Ken Labs as well, looking at index tool and performance testing. So with that, I'm going to give it up to Peter, and with PegaSys, it looks like, and you can start sharing your screen.
Hello, I will do the demo. Hello, everyone. So for the one who were at the previous demo, I have set up the same context than before. So just to summarize quickly, we have the gateways, we have all the components set up, client, a gateway, and a provider admin that allows to control this component, these components. So last time, we were able to demonstrate to you that when a provider publishes a file offer, the client was able to get it through the gateway. But we used a fake file to do it. So I will show you that now we have real file. So I will go to one of the provider container just to show you that we will do the demonstration with these 3 files. I will just show the content of one to see that it is real. Perfect. So today we will demonstrate the same mechanism that before. So it will be the standard discovery, the DHT discovery, but with real file. And at the end, we will demonstrate also our new caching mechanism. So first of all, the gateway has a list of files. Here is the gateway, the provider, sorry. We can see that it has a free file in this system. We will be able to publish one offer for each file with one different price for each. And the third one. Perfect. So now what we can do, we can go to the client, and first we will search for the different gateway around the client. Currently, we have a country code mechanism that is not implemented because, as previously discussed, we are still working on the geolocation mechanism. So we will move forward on the one that is in the architecture document. But at any point, if you have any insight on a geolocation mechanism, we'll be really interested to have a discussion with you. So I search for all the gateway around the clients. There are many. I will choose one. So I will add peer. It means that the client will use this one to query the offer. And I will search for the first file. You see the CID here. So I will try to find the offer. And I can see that the offer is retrieved. Now that I have the offer, I will retrieve the file. So to retrieve the file, what I do is I use the command retrieve. I use also the digest and a pass to download the file. Sometimes it takes a bit of time between, it's because of the payments channel setup. So what we will see, we will go on the container, the client container that I have opened just below. And you can see that the test one has just been retrieved from the provider. I'll show you the content. Okay, So it was for the standard discovery. Now we'll use the second mechanism. It is the DHT discovery, because we have two types of gateways. We have full gateways and minimal gateways, light gateways. A full gateway will store all kinds of offers. Minimal gateways will only store a few bunch of offers. So for the test 2, for example, we will query a gateway that don't have this offer, and we will use the DHT mechanism to get it. So first, you see the second file here, file test 2. We will ask for the client to search for this offer. Sorry. Find offer, return an empty value, because the gateway don't have its offer. So what we will do, we will ask the gateway to find a DHT offer to find through other provider if the gateway can retrieve it. So it instantiates a payment channel. It takes a little bit of time, but when the payment channel is set, the gateway is able to retrieve the good offer for the file 2. Like the previous mechanism, we can, once we have the offer, we can use the digest with a pass, and we are able to download the second file. And third feature, you see at every time we have to ask, the client has to specify which gateway it will use. So we have a retrieve fast mechanism. So I will do it for the third file. Retrieve fast is just an internal algorithm for the client. It will be able for the client to automatically find his content at the best price. Oh, sorry. I missed one parameter. Okay, retrieve fast. It has done all the sequence in a row. It has get the best offer, retrieve the file, and you can see that now the file is also retrieved in the client. Next part will be, last part, sorry, will be the caching, because it might be possible for a gateway to want to store popular file. Maybe a gateway will want to get more profits. So a gateway might wish to store the file from the provider and serve it directly to the client. There is a good incentive to do that for the clients. Also, is between client and gateway, payment channels are already set up. So if a client asks a gateway to retrieve a popular file and the gateway have it, and they used to discuss, payment channels are already set up. So file retrieval will be very faster than if it has to go to an unknown gateway. So I will demonstrate the caching. So we will choose a popular file. For example, we will imagine that, we will imagine that the test3 is a more popular file. So I will publish an offer for the test3. Sorry. Sorry, I missed a little of the subject. I will do it again. So I will create a new file to cache. So I will go on the provider, and I will create a new file from scratch. So let's create a test 4. The test 4 is here. We will upload the file. Oops. Oh, sorry, it is in the admin. We will list the file to see that it is here. We have the test 4, and we will publish the offer for a price of 400,000. So in the gateway admin, we will get an offer from this file. So the gateway admin will get the offer from the second file. And it is not working. Sorry, the caching mechanism is not totally well handled by me.
You probably, sorry, just to interrupt, you probably need to change the gateways. So by using set default in a gateway admin.
Yeah.
To be the gateway start by like 7.1, something like that. So try list to CID.
Yeah. List CID. Okay. Thank you, Chen. I think we have the second one, 9K. Perfect. So sorry, I'm not able to make it work. No, he's only able to find the offer from the provider. I'm not able to find the offer from the gateway.
Well, you can just use get offers on the gateway admin. So passing the last CID.
Okay, thank you.
And then you can cache it.
So I can cache the content. Use the digest for this file. Content is cached. Great. And normally,
yeah, then in the provider admin, switch to the provider that is running inside the gateway container. So basically, we achieve caching gateway by combining gateway and provider altogether. So basically, gateway cached the content to a path, then the provider is able to pick it up, then we can publish offers for that cached content.
So guys, maybe rather than monopolizing the whole meeting, we should.
Sorry, we will rehearse this part.
Yeah, it's okay.
But yeah, thank you for the demo.
So before we finish off our demo, any thoughts, questions?
A few questions posted on Slack. Let's follow on those, I think, and then if we have time at the end, we can bring them up as usual.
Sounds good. All right, so just so everyone knows, not that I'm not interested in the other demos, I'll watch the recording. I've got another meeting I should be at, so I'll see everyone. Bye.
All right, so now up we have Myel with Lazy Retrievals by Thomas, it looks like.
right. I think, can you see my screen right now?
Yep.
We can see, yeah.
All right, awesome. So basically, I'm going to start kind of with a use case that we've been kind of working on. And really what interests us right now is kind of looking at, at the use case of a simple blog. So what if you stored and cached a single simple blog on a Filecoin retrieval market? And so kind of what we were looking at is just a way to really remove, make the UX as seamless as possible, so you don't have to like load payment channels in between the user experience and interrupt the flow. And so that's kind of how we kind of came up with the concept of lazy retrieval, which is basically a way to estimate all the content that you're going to need for a session, and then prepay for it, and then kind of do a bunch of retrievals across multiple sessions. So for example, what I could do is if I were setting a blog, I could just start, by writing down my slug. So this is just kind of a sandbox. It's not really a user-facing interface. It's mostly for demo purposes. But for example, if I put a slug and I say I have all my cover images, so I would just kind of load a bunch of, images. So I'll just kind of add some here. And just maybe one less one. So here we go. So this is kind of, let's say this is all the content for my blog. So then I can kind of upload it to the gateway, and then get my root hash. And so then from there, I change node. So I'm going to use a local node. And so I'm going to start kind of a prefetch. So here I'm just setting the maximum price per byte. So I'm saying, I can tolerate any provider who will charge me below 6 FIL per byte. And then I'll just kind of retrieve. And so automatically I'm creating the payment channel. And so what happened here is this retrieval actually only retrieves the index of the file. So it's just a single node that just got retrieved, which is why you see the progress bars to the end. So I actually just retrieve a single node that contains kind of a map that has all the slugs and the CIDs of all those slugs, basically. And so right now I'm loading a payment channel, but for paying for the entire content of this DAG, but I've only retrieved the index. And so essentially, once I'm kind of done with this and I have that loaded, I can reuse that same payment channel with that peer and then progressively load all the content. And so it's actually, there's still kind of a lot of, questions around, there's a lot of complexity basically around deciding how to, establish this link between the client and the provider in terms of when can a payment channel be settled, when can it be updated, and making sure that, for example, the provider is in its interest wants to settle as quickly as possible so it can get some of the cash back, and the client wants to keep that payment channel up and open as long as possible, as long as there's still funds in it. So basically, we've been kind of playing around with the minimum settled height, which is kind of those parameters that you can set on vouchers. And so every time you do a transfer, you send an additional minimum settled height, which guarantees that the provider cannot settle the channel until that height, that chain height has passed, which makes sure that, for example, if I come back to this blog, so right now I have all my content is here, so I can lazily retrieve part of them progressively. So here it should it's just a tiny bit slow, but it should appear. Here we go. So I'm kind of like retrieving all these things. So now every time I'm doing block by block and sending more vouchers every time I'm doing this. So every time I'm doing this, I'm kind of extending the time I have that I can keep this payment channel. And so if I don't give sign of life, after a little bit, then the provider will just assume that they can redeem, those vouchers. And so they'll just compact it all into one voucher and then update the state and then settle it. And there's also a thing where it makes sure that there's also the different parameters that you can use that are like the minimum settle height and things like that. So it really validates those vouchers to make sure that it will work with that as well. So for example, a provider could decide to refuse a transfer and cancel a transfer if the vouchers and the parameters of the vouchers are not up to their standards and things like that. So here, I'm doing all those retrievals. And so I can kind of show you what's happening here. So you can see all the different like retrievals that happened. And when I kind of created my payment channel initially. And so I can say that initially I only spent 495 autofills on this first thing, on this first block. And then basically it's doing all the different graph-sync transfers and data transfers every time. Seems like this is not accurate, actually. There should be some fill here. But yeah, this is all on mainnet. The black hole is not coming through. Maybe it's a bit heavier. And so, yeah, so this is all on mainnet. And we're still solving a few things and actually trying to basically look at how and when the payment channel is initially loaded, because there's still that wait time. So we're looking at, doing this in the background in like a service worker and things like that. And so every time there's basically new content. So if I'm subscribed to a blog or something like that, you could push those updates, those CIDs, and then automatically preload the channel for that content. And then next time I'm going and I'm browsing the content, it's already loaded and I can load it right away as I scroll and everything. So you get that really smooth experience and you have no idea all the stuff that's happening in the background. So we're really hoping to ship that soon as like a really kind of concrete, developer use case.
Wonderful. It looks like there are a few comments and questions for you in the Slack channel. So make sure to take a look at those after the rest of the demos are done. Thank you so much, Thomas. Finally, it looks like today we have Ken Labs demoing an indexing tool and also some performance testing as well. So I'll let you take it from here.
Hello, this is William from the Ken Labs. So I'm going to share my screen. So can you see my screen?
Yes, we can.
Cool, thanks. So this is the agenda for our demo. So we have 3 parts. So first of all, Ben is going to introduce our IPFS watch enhancement with the URL resource support. So which is we committed in previous demo, after previous demo. And the second part is the performance testing. So we did a round of the testing against the IPFS file add interface. So I'm going to present on behalf of our colleague, Zhang Xiang. At last, I'm going to give a brief introduction about our indexing service. That's an overview. And for more details, we will go on Slack. So I'll hand the ball over to Ben. Hey, Ben, could you please share your screen and start? Thanks.
Ben, I don't think we can hear you.
You might be muted.
It seems it's unmuted, but I do see your mouth moving, so maybe it's not the right microphone. Next to the mute button, you have a little arrow pointing up that you can pick your microphone there on the Zoom interface.
Next to the mute button, there should be an up arrow that you can click to then pick a few different speakers.
Still no luck, Ben. We can still we cannot hear you.
Hello, William. You can go first, and I will give a call to Ben. Is that okay?
Mm-hmm.
Yeah.
That'd be great.
Okay. So let me share my screen for the performance test. Let me see. Okay, so sorry for the delay. This is the IPFS API performance test we did in past 2 weeks. Let's see our objective. In general, we try to understand how IPFS behaves in handling different file size, especially the large files. In this way, it helps us understand what kind of file we can handle, and in our future, the indexing service, what we need to do, and what kind of file we need to prepare or even handle. So this is one of the objectives. And also, when we have the outcome, it can be the guidance to our future work in designing the indexing system. This is in general the test plan. So we just test the file add interface, the API, the HTTP API. The steps are simple. So we run the add operation with different file size and illustrate the trend of the different indicator or the measurements. For example, the response time and the transaction per. So here we are using transaction per hour and the CPU memory usage. So this is the plan. And we use the, this is the software and the hardware. And we use a laptop, and we have this software versions listed here. We use IPFS 0.9, and we run in Docker. And for testing tool, we are using JMeter. And so this is the environment setup. So let's see the preparation. Due to the limitation of our test host or test server, so we just prepare 1 GB, 10, and 30. For test tool, we use Apache JMeter tool. So this is a screenshot of the tool.
I'm not sure if we are seeing the right slides. It still shows the title slide to me, IPFS API performance test.
Oh, really?
Yeah.
Let me see.
Oh, I see. There was.
Can you see now the preparation?
Yeah, now we can see the whole app. If you can use this format. That's okay.
Yeah, there might be some problem with the keynote with Zoom, so I just leave it here. So if it's okay to you. Okay, so it might be too small for you. I'm not sure if you really can figure out those figures, but I'm going to share with you the result and the analysis. So in general here, on the left side, so it will be in the same pattern. So left side, it's the test against different file size. On the right side, that's the metrics against different chunk sizes. So we can see the larger the file is, the more time it takes. So which is apparent. And on the right-hand side, you can see by increasing the chunk size, it cannot always increase the processing speed. So in practice, it converges at some point. So what we learned from this case is that we should run testing with different chunk sizes in practice to find the size that suits our use case or test case. So this is a response time. I forgot to mention that this is response time of the API. So you can see
impacts on the file size and chunk size. And this is a transaction per hour. In general, so by adding files with same size, the larger the chunk size is, so the higher the TPH is. So in this way, we can say that we can try to, in general, we can try to increase a bit the chunk size so that we can get a better performance. I'll show you more summaries later. So this is the data we collect. And this is the CPU usage and the memory, CPU and memory usage consumption. And the left side, it's the metrics on different file size. On the right side, it's the different chunk size on the same file. So it's not very straightforward on the right-hand side. I try to solve the x-axis issue. So you can see there's just 1G. So it's not the real x-axis. So this is actually for, so if I go back, we test with chunk size 0.5, 0.25 megabytes and half and 1 megabytes. So these three chunk sizes. So these are reflected on the chart you see here in the on the right-hand side. So in general, I'll say that the larger chunk sizes, the higher TPH on the IPFS side in general, so we can increase the size a bit. So this is the second result. So if we go to the third one, I just mentioned the CPU and the memory. So the consumption, the memory usage or CPU usage are highly dependent on the runtime environment. But in general, no matter what the file size is, increasing the chunk size can cause a higher CPU consumption. So this is one factor we may need to consider when we handle the large file. So this is the result. So in summary, here the test performance test revealed how the IPFS works in adding files. And in practice, I think we need more performance tests, especially we want to cover more file size and the chunk size. And when we say file size, it means that some file larger than 30 gigabytes, so say 100 or even 1 TB, that will be more practical and give more confidence in the future work in terms of, for example, the indexing service design. So this is the summary, and we have also got the action plan. So for the performance test, we may have the phase 2, which cover what I just mentioned, the file size and the chunk size. Apart from that, we also have the command line interface improvement. So when we did the test, we noticed that, so when you add a small file to the IPFS, it's quick and you won't need to wait. But when we handle or when we deal with a large file, so the command line execution will hang there until it's completed. So in this way, in this case, it might happen that sometimes the user might break the execution, so which is not ideal. So I'm thinking if we can do it in a sync mode so that the execution or the task execution can be put in the background, so the user will be responded with some information or message that the execution is in progress, and by some means we can also pull the progress of any command execution or task handling. So it will be more reliable and hopefully it will be more robust. So this is the performance test we have conducted in past 2 weeks. Thanks. Also thanks to Zhang Xiang, who is not able to participate today. So I'm presenting on behalf of him. Thank you. Let me see if Ben, are you okay to present? Cool. Yeah, I think I hear you now.
Okay. Can you hear me, guys?
Yes.
Sorry. Okay, let's begin. Today, I'm going to share with you a tool which can synchronize files on local machine or remote with URL to a IPFS node. Our work is basically mainly based on IPFS sync and IPFS watch. So now let's start. So the first step here is to start a IPFS node on my local machine. So just to run this command. Okay, now daemon is ready. Let's check it. Okay, let me delete it. Okay, now here's my use case. There is a directory called sync test at here. So I'm gonna sync this directory to my IPFS node. What I'm gonna do is to run this command to just run IPFS watch, and this tool will to start check my local directory and sync the files if it's different from my local files to my IPFS node. Oh. Sorry, there's just some problems occurred at here. So can I just finish this demo? And
Okay, so you need a few minutes. So we should do the last segment and then come back to this one. Is that it?
Yeah, I can. If it's okay, that I can quickly go through the indexing service overview and hand the ball back to Ben.
Yep, that'd be great.
Cool, thanks. So let me share my screen again. Okay, so can you see my screen?
Yes, we can.
Okay, so this is what we are working on for now. So indexing solution design. So the objective is that we want to have a solution to index the the CIDs on the IPFS network with not just the CIDs, so sets, also with their associated attributes for faster content routing and the discovery. The idea that we want to give a solution that user can search the sets, also do some meaningful search, for example, full text search, which will be based on some semantic index. So this is the way or the goal we want to achieve. So we define some very generic data structure. So the intrinsic attribute index, this is to give you some insight of the set. So for example, if you put some file with a file store to IPFS, so the data is not copied to IPFS. Instead, you have the file path and the offset, as well as the size of the block or the accumulative size. So in general, all this information, the intrinsic attribute. So we want to have some kind of index on that information. Well, I just put the organization attribute here. This is to indicate where this data from, for example, from any organization, from any institution or some university or some company. So this is a very generic purpose for the organization. It can be expanded or extended. And besides the IA index, we also define the EA index. So this is an extrinsic attribute. So this is some index that should describe the data or the block so that we have some semantic information of those data. So for now, we haven't defined the interface, how we can produce or set this kind of attribute to the data or the set. Some way can be that we can leverage manual labeling of the data so that when you type IPFS add file, so we can have some option to allow user to tag or label the file. So say this is some very useful technology article that you can share. So this is some semantic information. Besides, we can also use some deep learning algorithm or the NPL so that we can train some model or produce some algorithm so that by learning or by feeding loads of data or information to the model, we can build the kind of robot or service to automatically label those files for you. So you don't need any manual intervention. So this is the extrinsic attribute. So when we have these indexes, so we can set up the index entry. So this is the entry for each set. For each set, you have these two attribute set types. So for each, you can by some means populate them to the entry. And then we archive those entries into a index archive structure. In this type, there are two main aspects. One is the peer. So this is to identify which provider has this content. The rest is the entries list. So this list shows you who has what content, including, or actually, when we say content here, that's the index. And this is advertisement. This is to advertise what this provider has to the public. So we can publish a message to some pops-up topic, and any subscriber will receive and store or process those index data for any customer needs. So they can also expose interface for different kind of purpose in very generic search or full text search. So they can build based on that. So this is advertisement DAG. So this is how we manage the advertisement. So it's not reliable that the subscriber can always be online and the subscribers can always receive and query the advertisement from provider. So we need a kind of mechanism to maintain the advertisement chain. Every time when you receive an advertisement from the topic, it's not guaranteed that you receive the latest and that you have synced all the previous advertisements. So in this way, the data provider maintain a chain. Every time when you receive the data subscriber receive an advertisement, it will try to fetch it from the data provider. At the same time, the provider will respond to the previous advertisement. So the subscriber can then see if it has already synced that one. If not, so it will walk through the chain to sync all the content or the index from the data provider, so that the indexer node can try its best to keep up with the data provider's index. So this is the idea of this data structure. And we define the interface. For now, we just defined when the indexing feature will be enabled. So I am going to talk about the indexing feature shortly. So in general, we want to introduce another option in the IPFS add command. So you have the -- index. In this way, the IPFS node will know that we are going to produce the index for the new content. And there's just some open issue here. So what if the other file is deleted from the local file system? So this question is about the file store. When we use file store, and we know that the content is not copied to the block. So what if the file is deleted, so the block becomes invalid? So how can we handle it? If on-ping and the garbage collection is enough, so we need to investigate, we need to find a solution for that case. Also, if the file store, I'm not sure if a file store will be a permanent feature or solution. If not, we need to find the alternative to that, so that we can still support the huge file on IPFS, so that we don't need to copy the file content to IPFS node. At the same time, we can support most of the features to the end user or the customer. So this is the interface of the IPFS node. So indexer node, I mark them as red. So currently we are investigating the use case or the feasibility of store the index project. So in general, it has already exposed a list of interface as I list here. I'm not sure we still need the import. So probably yes, so I mark as red. So we are still investigating. This is the architecture. So there are a couple ways to feed the data to IPFS. So end user by command line, or the IPFS watch what we are working on through the HTTP interface, or maybe through via other protocol, or the IPFS crawler. The crawler is going to crawl or walk through the whole IPFS network and collect data, collect the blocks, or maybe other type of data. So maybe a collection of blocks. It's not clear yet. In general, the data will be coming from crawler and feed to the IPFS node. So going through this tech stack, when we have the DAG, the DAG from the block store, we can start building the index. So that's a raw data sent to the indexing feature. So when I say indexing here, it's a feature we are going to introduce to IPFS. So here, in general, we are going to publish a message to the topic, a pop subtopic. And here, the index node, which is we are also working on, we are investigating, as I said, store index, the project. We may want to extend that project to subscribe to some topic to collect the advertisements, then fetch them from the IPFS node or its data provider. So the index node will build more featured indexes So including the, as I said, the semantic index or the intrinsic attribute. So they very straightforward, how to say, the plain index, so that it will give the interface to external users to build more reliable or more advanced application or features. So this, in this index node, we are still designing. So here, so it's not finished, but now we have done the index feature design part. So this is the feature design and the workflow, and this is sequence diagram. We haven't started the implementation yet, so we're still reviewing this design. So later, probably Tao is also going to post this design to the channel. We can talk about this design more, and any question or advice is highly appreciated. So we will go through and give a update in this design if needed. Hopefully we will also have some outcome in next few weeks. Yeah, I think that's probably me. Let's go back to see if Ben is ready for a demo.
I think there is some environmental issues of Ben's side. So the demo of Collabs is finished, I think, on that.
Okay, would it be best to wait for the next demo day and then Ben can present then?
Yeah,
sure. Yeah.
Okay, let's do that then. So for everyone, just a quick reminder, these are every 2 weeks. So the next one will be August 18th, same time. It's a Wednesday, just like they normally are. Make sure everyone goes in to the Slack channel to take a look at some of the questions and the answers that were provided there. And there's also, looks like, some suggestions as well. So thank you again, everyone, for coming today. We really appreciate it. Reminder again, these are every 2 weeks. So August 18th, the next one, like I said. And for anyone who wants to see the recording of this or potentially go back and rewatch any of it, this will be uploaded shortly. And I'll be putting the link into the Slack channel as well for everyone for a quick and easy use. All right. Thank you again for coming, everybody. We appreciate it.
Thank you.
thank you.
Bye-bye.